How to use the Relight node in Nuke to add shading and 3D lighting to our render. So I've got a blank script here, and let's import a 3D render from whatever 3D application we're using. And I was given this, and I need to add some rim lighting to this to help separate the character from the background. Now there's lots of different ways to do this with rotoscoping, with painting, but one of the fastest ways is using the Relight node, and this was added in Nuke 7.0. So I'm going to hit Tab, drop in the Relight node. Now it looks like it only needs 2 ports, or it only needs 2 nodes, a color and a light. So let's plug our color in, and let's just drop in a normal 3D light inside of Nuke, and plug this into lights, and take a look. So as you can see, as soon as we connect the light, it's going to tell us, or it's not going to give us any color information. And that's because it actually needs quite a few more pieces of data before it can accurately relight. Relighting is sort of a mathematical trick in compositing that requires a bit more information. So if we go back to that footage folder, I've added the normal and world.exr passes. And I've just output these out of our 3D application, and it's a very fast render because it is simply reading 3D data and exporting the passes from this. So while these are 2 separate images, you could of course render these in a layered EXR and use them from there. So if we take a look at this image, we just have some basic throwaway RGB data that I turn the settings down so it would render fast, and the normal world in our camera, which looks like this, and a world point position pass, which usually looks something like this. Now these are both floating point EXRs, so you can see they've got high dynamic range data, and that's incredibly important. This will not work if you're using an 8-bit format. And if we go into Relight, the color pipe is actually asking for the vectors and the normals and the point positions. So I'm going to plug the EXR we just imported, and in Relight, let's drop our vectors, or our normal vectors, down into normal, and our point position into our world position. Still, however, if we look at the RGB, nothing's happening. It's because it needs 1 or 2 last pieces of data. One of the external factors is it needs a 3D camera. So I've gone in and exported an FBX of our camera from this 3D application. If you have a camera in Nuke, you can use that as well. I'm just going to drop in a new camera and then import our 3D camera from this FBX file. Just click yes. And so you can see here this next pipe is a camera. So I'm going to drop that on, move that over. And finally, the last things it needs is a Nuke material. So we can come over here to our shaders, and you can use whatever material you like. I'm just going to drop in a basic material because it has lots of controls. And we drop our material on, and now we can see the relighting happening. However, we haven't really placed our 3D light, and it's difficult to tell what is actually going on. So let's begin by placing our light, and then we can talk a little about what the Relight node is actually doing. So if we hit Tab to go into our 3D scene, we can hit the F key on our light. Let's see, we can hit the F key on our camera, and we can not see anything else other than our light and our camera. So this is the first problem people run into. But since we have a world point position pass, we can use the the position to point node. This is kind of a rare node. You probably don't encounter this too often, but it's incredibly useful for placing things in 3D and just working in 3D in general. So I'm going to hit Tab and drop in the position to points node. And this requires, again, a surface normal and a surface point pass. So I'm going to plug these into our EXR. And let's drop our channels down to the point, the world position, and our normal. So what that did is it actually created a point cloud based on those 2 images. And so what we see is our image actually in 3D space. Now this is not a 3D model. You'll notice if I go to the back of our character's head, it's completely empty, and we're missing quite a few places in our character. And that's because it's simply reading in the image information. So if there's a pixel for it, it will appear inside of our point cloud. However, if that piece of geometry is hidden by another pixel, then it will not appear. So we can see that we can modify pixels we can see, but we do not have the full geometry. Okay, so now we can see in 3D space. So let's grab our light and let's come in and place it correctly to give us a rim light. So I'm going to zoom into this light, and I'm going to change it from a point light to a directional light, so that it is constantly casting light in a specific direction. And I'm just going to rotate it so that the light is facing, sort of facing away, or lighting away from our character, so that we're only getting the rim of our character instead of the entire character. Okay. See that? And so now we can see we have only a rim area, and I'm going to continue just rotating this just for a second to try and get the best possible lighting. And of course the lighting is going to be very specific to your scene and your image. But this looks pretty good for some rim lighting for our character. So now let's merge our relight result over our original image. So I'm going to select the relight and our read node and drop a merge on. And here that is. And I'm going to change this to add or plus, because that's essentially what light does. And now you can see our light is correctly casting and correctly shading based on the normal and the position. So our light is kind of pointed backwards, so you can see we're actually getting some rim lighting on our nose here. And the light is, of course, a little bit or quite a bit too bright. So we can come in and reduce the intensity, and let's actually give this a little bit of shading so it kind of matches his skin. And you'll notice one of the first problems with relighting is that it does not adhere to geometry restrictions. So you can see we're lighting the inside of our nose, we're lighting our hair. All of this would be blocked by the geometry of a normal light. However, in this case, again, we are just tricking Nuke into applying our shading. Now you'll probably notice a second problem that often crops up with relighting is that the edges will not match, and they will never match. And that's because whenever you export this normal and world pass, the renderer has to output this on a per pixel basis. So you're not going to have any separation between these pixels, or you're not going to have any aliasing or anti-aliasing. You're going to, in fact, have this very pronounced stair-stepping. And that's just kind of one of the problems with relighting. So you can either separate your objects, or you can render your data passes, this normal and the point pass, at a much larger resolution. So to take a look at that, I've dropped in an alternate normal and point pass that I rendered out that is actually twice as large as our image. And this renders out actually relatively fast because, again, this data is already in your 3D application. It's not having to calculate it or process it. It just has to export it. So this is relatively cheap in terms of render time. And if we replace our relight or our color to our normal world large, what we're going to see is much nicer edges. And that's because, again, we're just throwing more data at it. If I could, I would go 4 times as large, but that tends to get rather large in terms of file size. Now, since we are using a different size image, we're going to have to reformat our relight output. So I'll drop that on to our target format, which in this case is 720p. There we go. And now we can see our edges are actually much, much nicer than they were before. However, we're still having a little bit of a problem. To solve that a tiny bit, you could go into the relight node, and if it's on a normal edge, you could use alpha, and that will try and use the alpha channel to affect or stop the relighting process. Okay, great. So what we've done is we've actually gone in and used a 3D light inside of Nuke to relight our image. And of course you can go into your material, maybe turn down the specular a little bit, turn up the diffuse. Let's say you want more than one light. You want a little bit of green light on his shoes. To use more than one light, again, like I said earlier, we could use a scene node to combine those. Since this is a 3D environment, you can use the scene to bring in multiple lights. So I'm just going to drop in a new light node, plug this into this scene, and we can see this immediately has an effect. So this second light, I'm just going to place by his shoes, and I'm going to give it a little bit of a fall off, quadratic fall off, and then bump up the intensity, just to give it a little bit more of that green bounce back that we might expect. Okay, great. So let's take a look at that change. So we can see we've added a little bit of green light in this area. Of course, we can come in and tweak this for days. Relighting is actually one of the most fun things about Nuke. Not only because we're working in such a rich 3D environment, but because you can make such powerful changes to your images so quickly and so easily. As you can see here, I can just move this, and it immediately affects our 3D or our 2D image correctly in 3D space. So here is our final image with the rim light applied, and you can see that by relighting this, or by adding that relight node, we can really come in here and customize our images and add lighting, add specular highlighting, add all sorts of things to an already completed render. And again, this only requires an extra few clicks for our 3D render artist. So if you can get the normal pass as well as the point pass and a camera, you can use this extremely powerful node here inside of Nuke.